Let's do problem 27 on page 242 of your book. And let me read the problem out loud. It says, Robin pushes a wheelbarrow by exerting a 140 Newton force horizontally. Robin moves it 60 meters at a constant speed of 25 seconds. A, what power does Robin develop? And B, if Robin moves the wheelbarrow twice as fast, how much power is developed? So let's do the given, find, and solve thing. So given. So we've got some kind of a horizontal surface. And let's draw a wheelbarrow. Let's see if I can draw a wheelbarrow. Not very good. Here's the handles on it. And anyway, Robin, I don't know, she or he, doesn't matter. Applies a force, and it says that force is 145 newtons. So the applied force, 145 newtons. And the displacement is 60 meters. And at least this is the problem for part A. Well, we'll deal with that in a second. And what are we trying, and oh, they give us the time. And the time it takes to do that, the time is 25 seconds. Okay? And for part A, what are we trying to find? Well, it wants to know, calculate, or it says, what power does Robin develop? So let's solve. Now, power equals the work done divided by time. But watch this little trick here. The work done is the force applied times the displacement times the cosine of the angle between the force and the displacement. And then, of course, we divide that by time. By the way, look at this. Delta x over t. This is our displacement divided by the time it took to make that displacement. What is that? That's our speed, that's our velocity. So we can call power work over time, but we can also call power force times velocity, which will matter to us when we get to part B. But in any case, now all we need to do is plug in our values. We know the force is 145 newtons. Delta x is 60 meters. Cosine theta, well, theta, they're both to the right, so they are in the same direction. So the angle between them is 0. Divide that by the time, it's 25 seconds. And when you plug all that into a calculator, oh, somebody borrowed my calculator. But I do believe when you do that, you get 348. And a Newton meter is a joule, and a joule divided by a second is a watt. So the power equals 348 watts. Okay. Now for part B, it says we want to find the power if moving twice as fast. Isn't that right? So you can look at it two different ways. I'm going to look at it this way. I'm going to look at this. They say this is really the force times the velocity times the cosine of the angle between them. But if you have twice the velocity, that means it's going to be force, well, it's going to be what we got before, just twice as much. So if this is really 2 times our velocity before, that we had before, this is really twice the power that we had before. And so the power is equal to, what is that? 2 times 8 is 16. 2 times 8, 9. And 696 watts. But one thing to learn from this is that power, you can think of power as being work over time. That's the definition of it. But work is a force times displacement, and if you have displacement over time, that's also velocity. So you can think of power as being force times velocity as well. Okay, and that's how you do that problem. Any questions? Okay, that is all.